Good evening, everybody, and welcome to my video. Tonight I wanted to do a second installment on the scales here. One thing that I wanted to mention about the architectural scale, that's the architectural scale there, is that where the 16th grading is right here, that can also be used as 1-to-1, okay? Instead of 12 feet, it can be 12 inches so that you can measure something 1-to-1. I just wanted to bring that up for that, okay? And the importance of the decimal scale as opposed to the fractional scale. Now the fractional scale is only good to, well, this one here is a 16th. So it's only, you can only measure a 16th of an inch relatively accurately, okay? So even if you go to a 32nd of an inch, you still have a 32nd of dimensions between the whatever 30. So like if you're using you're going from 0 to a 32nd, there is a whole bunch of numbers in between there that you can't get fractionally. Okay, you have to, go out to like 1 and 1/32 or something like that to half this 64. So you can't get down to like 1/1000th of an inch. Okay, so that's what a caliper is for. Okay, now this is a dial caliper. Okay, and this will measure a very small part. Okay, so what we're going to do is we're going to take this little, I get this little post-it note right here. Okay, so if I take it over here and put it on a scale, there's no way with this scale here that we're going to measure the thickness of this post-it note. But I can stick it in, I can put it on here. Okay, I got that zeroed out to 0. Okay, that's on 0. Let me bring my light over here a little better. Okay, that's 0. Okay, so what I'm going to do is I'm going to stick this piece of paper in there, and we're going to measure the thickness of this post-it note. Okay, I can get it to go back together with one hand. Now that post-it note is 4/1000ths of an inch thick. Okay, can you see that? I don't know if you can read the numbers on there, but you can see the dial is no longer on 0. Okay, that post-it note is 4/1000ths of an inch thick. You cannot measure 4/1000ths of an inch thick with a fraction. You just can't do it. Okay, but you can measure 4/1000ths of an inch thick with decimal scale. Okay, so what I mean is, if we start out with 0, okay, and then we're going to 1/32, okay, well, we can just use this chart right here. Okay, so if we look at this chart right here, the first we have a 64th of an inch. It's as low as it goes. Okay, but that's the decimal equivalent to that is 0.015625. Okay, so if we go to the next 64th, which would bring us to 1/32, that is 0.03125. Okay, so the difference in between the two of those is 0.015625. Okay, so you have all those numbers between there getting from 0.15625, and then you got 0.15626, 0.15627, and so on until you get to a 32nd. Okay, well, the decimal allows you to take advantage of every number in between the two. Where when fractionally, you can only go as low as your fraction is. So if it's a 64th, that's as low as you can go. There's no in between that, unless you go to 1 and 1/32. Okay, well that'll get you in between the two of those, right in the center. Okay, but if you want to get in between that, then you have to go 1/264. Okay, so if you want to split that down again, then you have to, it just keeps building and building, and the next thing you know, you got some crazy fraction. Okay, so that is the importance of the decimal scale. Not only can you use your engineering scale or the decimal scale to um, measure very large objects to put them on a piece of paper. Okay, but you can measure very small objects to get their tolerances and stuff correct, so that you have fine fits. So if you're looking for accuracy, the decimal scale or the engineer scale can be said to be more accurate. The decimal scale is more accurate than the fractional scale any day of the week. There's no comparison. You can't get down between. I mean, how do you express 0.015627 in a fraction? You can't. You have to round it off. Well, as soon as you round it off, you've already thrown your tolerances out for a bearing journal. Okay? Because now you either have to round it up or round it down, and then if your tolerance is, if you have a 0.02 of an inch clearance in there, and you have a tolerance of a 0.005 of an inch, and your dimension is 0.01572, and you want to round it down to a 1/64, well, that bearing journal is going to be sloppy. It's just not going to. It's not going to work. Nothing's going to fit together because it's too sloppy for a tight tolerance. Okay, so the decimal scale is the only thing that you can use when you get down to, say, the thickness of a piece of paper. You cannot measure the thickness of a piece of paper with a fractional scale. You can only do it with a decimal scale. Okay, or millimeters. Millimeters will take you down to that as well. So millimeters and a decimal scale is basically the same thing. They're base 10. It's just that the distance is different. Okay, so the number, you get the same distance, the same length, but as you mark the distance, it's different. That's the only difference. A millimeter is smaller than an inch. So that's just, it's just a different gradient on the scale, different gradient scale, but it's all the same. It doesn't matter to me if I use metric or a decimal scale or fractions if I don't have to use a tight tolerance. Okay, any one of those will work. What I use to dictate how I design something, if I'm designing something from scratch, my first question is, what kind of hardware do you want to use? Okay, so if say somebody has a bunch of flathead cap screws, okay, and they're all flush mounted, okay, and they're looking for good surface area for that when you bolt the pieces together so that the bolts don't pull out. Well, SEA has a specific taper, and a millimeter has a wider taper, and then there's a military grade SEA that has an even wider taper. Well, the wider the taper, the more surface area there is, so the more holding power the head of the screw has. Okay, so if you're looking for that, it would behoove you to use a millimeter, or to use metric, because the surface area of the bolt head, there's more surface area. Okay, so in that kind of an application, I would recommend using a millimeter, because in order to get an SEA flathead cap screw that has an angle that it's a little bit greater than the millimeter. It's a military grade bolt, and they're expensive. So it's cheaper to use metric in that application as far as the screws go. So that would dictate the rest of the drawing. So if my hardware is in metric, then the whole drawing is in metric. All the dimensions, everything. So everything is cohesive and everything is the same on the drawing. Okay, because if you're going along and you're using metric, and all of a sudden you throw a decimal in there, well, that's just going to screw everybody up. Nobody's going to know what's happening. Okay, so you have to be consistent on your drawing. Okay, and so that's one of the ways I figure out when I'm designing something for somebody or for myself. There are little things like that you can ponder before you start your project. And sometimes it'll be easier to use decimal scale, sometimes it's easier to use a millimeter scale, and sometimes it's better to use a fraction. Okay, the fractional scale. So each one of them has their advantages and their disadvantages. Okay, um, so you can chalk it up to personal preference or anything like that. But there's kind of little rules of thumb that I use so that my drawings are cohesive. So that they're easy to read, they flow. Try not to crowd anything on them or anything like that. That's just what I try to do to make it as easy to read as possible. And if you're not sure if you need a dimension somewhere, put it in. It's a lot easier for them to ignore a dimension than it is for them to have to contact you, and you have to go back through all your information and everything and work out your calculations or everything like that, especially if you're doing stuff by hand. Now, if you're using a CAD system, most of the information is right there at your fingertips at any time. But if you're doing stuff by hand, you have to do the calculations. And sometimes, it might take you 2 weeks to figure out one dimension, depending on where it's at and, how complicated your part is and whatever, So, you're better off, I think, to put, if you're not sure about it, put it on there, okay? Because they can just discard it, okay? And if there's a way to get to it through machining process that you end up with a specific dimension through the machining process, then you can reference that dimension. And that way they know after they machine the part, if they measure it, this little angle on the part right here is going to be this. Even though you don't need the dimension to get the part, to make the part. But you can put the dimension in there for the machinist so that he has a reference so that he can go back and say, well, I did this and I did this and this dimension should be this. Bang. And it is. Okay, well then it must be right. Okay. So, but you have to be careful about doing that too, because you don't want to overload the drawing and make it too busy, because then it makes it harder to read. Because some drawings, are inherently busy to begin with. It depends on how intricate the piece is. So, but anyway, I hope that helps a little bit too. As you can see, the decimal scale is more accurate than the fractional scale. There's no comparison to the two when you get down to very small increments. Okay, now when you're talking about designing a building or something like that, then either one you can use. Either one will be just fine. But when you're getting down to really, really small, fine dimensions, very tight tolerances and stuff like that, there's no substitute for the decimal or the metric. You can use metric too. Metric is our decimal system is basically the same as the metric system. Like I said, the increments are just different. But like I said, as long as you have consistency through your drawing, it doesn't matter if you use metric or decimal. Um, Between the two, they're basically the same. There's, like I said, it's just the increment is different. So, but as long as you have consistency through your drawing, you don't have to worry about nothing. That shouldn't, you know, any machine shop should be able to make your parts, and if you're making your own parts, you'll find that it might be easier for you to do some of those little extra steps just to give you peace of mind. So when you make your part, you can check it. Okay, so I don't know. I think I'm rambling on again here, but I wanted to bring that up. I was hoping to get a veneer caliper, but I was able to get a hold of this dial caliper, and it actually makes it easier to understand because it's easier to see. Because I probably wouldn't be able to zoom in on a veneer caliper, but and then they have digital ones too. Um, but digital ones are great for the layperson because they don't have to worry about reading the thing properly. Not that it's real hard or anything like that, but the digital, it just gives you the readout. But you will find that a seasoned machinist don't like those. Okay. Um, I go to machine shops and I never see digital calipers laying around. They're always either dial or veneer. Because I don't know if they're more accurate, if they don't trust the electronics or what it is. But usually you see dial indicators or veneers. Most of the time it's dial indicator, um, because it's easier, to take a quick dimension without having to add everything up to get your dimension, because you have to add, the different numbers, the different whatever the positions are to figure out what the dimension is. Where a dial indicator, it just brings it right on. So you would take the number on the scale that's right here, this little number right down here. Okay, so wherever that is, that's got it. I don't know if you can see that there, but that's just past 2. So right now we're reading, let's see if I slide that back to 10 right there. So right now we're reading 110 thousandths of an inch. Or no, it'd be 2. So it'd be 0.210 is that distance right there. So it's a little less than a quarter of an inch. A little bit less. So if we come over here and I stick it on that scale there, you can see it's just a little bit less than a quarter of an inch. Okay? But you cannot get that using this scale. Okay? You can't get that dimension right there with that scale. Okay? You can only do that with the decimal system, which is what this works on. This works on the decimal system. Okay? Same with all micrometers work on the decimal system. Anything that measures small increments works on the decimal system. Okay? So I hope that clears up that. Like I said, this one here, it's the 16 scale, but you can use it as a 1-to-1 also. So it's that scale right there serves 2 purposes on this scale here. So on this triangle scale. So now I'm just rambling, I guess. So I'm gonna go ahead and call it a video. Have a wonderful day. Peace.